energy of electron in nth orbit. Slightly difficult because of formula epsilon naught n square h square pi m a square into z याद नहीं होता है, तो जरा बहुत बार लिख के प्रैक्टिस कर लेना. Generally, they will ask proportional to this n square upon z type, but we don't know if our luck is not favoring. They may give generalized single वाले का पूछ सकते हैं. So energy of electron in nth orbit. See, whenever energy is asked, then it is always kinetic energy, potential energy, and then total energy by first postulate. We know m v square by r is 1 upon 4 pi epsilon naught z square upon r square for any atom. Electron रहेगा तो ये 1. r cancel. If I multiply both side by half, then half mv square will be 1 by 8 epsilon naught ze square by r. Is this nothing but kinetic energy, which is ze square upon 8 pi epsilon naught r? So for nth orbit, we can say it is ze square upon 8 pi epsilon naught r nth orbit. I hope you followed kinetic energy.
Yes, sir.
Now potential energy between proton and electron is 1 upon 4 pi epsilon minus E into ZE upon distance R. याद आया ये फॉर्मूला इलेक्ट्रोस्टैटिक से 1 upon 4 pi Q1 Q2 upon distance.
Yes.
So minus ZE square upon 4 pi epsilon naught R. That means potential in nth orbit is minus ZE square upon 4 pi epsilon Rn. What will be then energy in nth orbit? It is energy in nth orbit En is kinetic energy in nth plus potential energy in nth. Okay? Not followed?
Followed.
Z E square upon 8 pi epsilon naught radius minus Z square upon 4 pi epsilon Rn. What is LCM of 8 pi epsilon naught and 4 pi epsilon naught Rn? 8 pi epsilon naught Rn. Okay? So Z square minus 2 times Z square. So E in nth orbit is minus of Z square upon 8 pi epsilon naught R in nth orbit. Please copy till this, then I am putting Rn value. We will get required answer.
Done, sir.
Will I clear now?
Yes.
So we got energy in nth orbit as minus ze square upon 8 pi epsilon naught Rn. What is Rn? Just now we derived epsilon naught n square h square upon pi me square into z, है ना? This was radius in nth orbit.
Yes.
So En will become minus ze square upon 8 pi epsilon naught n square h square upon pi me square into z. Now if I take this in the numerator, then we'll get minus z square e raised to 4 m minus m e raised to 4 into z square upon 8 epsilon naught square n square h square. That means En is proportional to my m is constant, e is constant. So we get minus of z square upon n square. For hydrogen atom, z is 1. So En is proportional to minus 1 upon n square. Copy.
Done, sir.
For hydrogen atom, energy in first orbit is minus 13.6 electron volt. Second orbit is E1 upon 4 minus 13.6 upon 4, which will become minus 3.4 electron volt. Energy in third orbit is E1 upon 9 minus of 13.6 upon 9 minus 1.51 electron volt. Fourth orbit is E1 by 16 minus 13.6 upon 16, so it is minus of 0.85 electron volt. 16 into 0.16 into 8 will be 128, so remainder 885. Last one. 5 you have to remember. At least 5 energy. It is E5 upon 25 minus 13.6 upon 25. This comes minus 0.544. So first 13.6, second one 3.4, then it is 1.51 minus 0.85 minus of 0.544. So if you remember this 5, many times they will ask what is the energy released if jumps from third orbit to first orbit. तो दोनों का energy याद रहेगा तो direct difference is my answer. Right note.
Done, sir.
Okay. Derive expression for velocity in nth orbit. So by second postulate, angular momentum is nh upon 2 pi, that is mvr is nh upon 2 pi, v equals to nh upon 2 pi mr. So nth orbit will be nh upon 2 pi m radius in nth orbit. Radius in nth orbit we got epsilon naught n square h square upon pi m square into z. Pi cancel, m cancel, nh, 1 nh cancel. So Vn will become z e square upon 2 epsilon naught nh. So Vn is proportional to z upon n. For hydrogen atom, Vn is inversely proportional to n. Copy to this.
Done, sir.
origin of spectral lines in hydrogen atom. So by third postulate, spectral line is nothing but range of different band of colors when electron jumps from higher orbit to lower orbit. So that's why I'm taking third postulate. En2 minus En1 is h nu. So En2 minus En1 is hc by lambda. This is minus me raised to 4 upon 8 epsilon square n2 square h square, minus minus plus me raised to 4 8 epsilon naught square n1 square h square is hc by lambda. I have taken hydrogen atom, so z square term I have not written. Otherwise it will be minus z me raised to 4. We can take me raised to 4 upon 8 epsilon naught square h square outside, inside 1 upon n1 square minus 1 upon n2 square is hc by lambda. So 1 by lambda equals to me raised to 4 upon 8 epsilon naught square h cube into c 1 upon n1 square minus 1 upon n2 square. Now this constant me raised to 4 8 epsilon naught square h cube c is called as Rydberg's constant. M e raised to 4 8 epsilon naught square h cube by c is called as, denoted by r, is called as Rydberg's constant. Its value is 1.097 into 10 raised to 7 meter raised to minus 1. So 1 by lambda is r into 1 upon n1 square minus 1 upon n2 square. So this 1 upon lambda is also called wave number. So sometimes they can say find wave number. That time you have to find 1 by lambda. So I can also say this is expression for wave number. Now why it is giving spectral lines? For different values of n1, n2, there will be different values of wavelength corresponding to different colors of light. This explains origin of spectral line. What are those spectra? We have to study in energy level diagram. First you copy till this, then I am giving the note why it will give you spectral line. Then we will draw energy level diagram. That much we'll do today. Copy full.
Done, sir.
Just try it. Everybody's completed?
Yes, sir.
Just write down for different values of n1, n2, there are different values of wavelength. For different values of n1, n2, there are different values of wavelength. Corresponding to different color of light. Different values of wavelength corresponding to different colors of light. Called as spectral lines. This explains origin of spectral lines. Next, energy level diagram. Energy level diagram means we have to explain different spectrum whenever electron jumps from higher orbit to specified orbit. First orbit is called as stable orbit or ground state. What is energy of first orbit?
13.6 electron.
Minus 13.6 electron volt. Second orbit minus 3.4. दोनों में फर्क नियरली 10 का है ना, nearly 10 का difference is there, correct?
Yes.
Yes, sir.
And second and third minus 3.5 and minus 1.51 is nearly 1.5. So second and third will become closer as compared to first and second. These lines will be closer. Then third and fourth minus 1.5 and 0.8, 0.7 का difference और भी close हो जाएगा. Fourth and fifth minus 0.85 and 0.5.3 और भी close आ जाएगा. Bit more closer. The next will be very close. And finally, last few orbits will be like overlapping because last ka energy zero, difference will be very, very small. So here this is E1, E2, E3, E4, E5, E6, and last is E infinite orbit. Here energy is minus 13.6 electron volt, minus 3.4 electron volt, minus 1.51 electron volt, minus 0.85 electron volt, and fifth one is minus 0.544 electron volt. Last will be 0. N is infinite orbit. So here N is 1, N is 2, N is 3, N is 4, N is 5, N is 6, last is ... up to infinity. When electron jumps from any higher orbit to the first orbit, then series obtained is called as Lyman series. It falls in ultraviolet region. So any higher orbit to the lower orbit. Then it is called Lyman series. Any higher orbit to the first Lyman series. Any higher orbit to the first Lyman series. Any higher orbit to the first Lyman series. And any higher orbit to the second, then Balmer series. In Balmer series, it belongs to visible light. So here first three lights are spectral lines are also called as H alpha and H beta H gamma line. H alpha means first line, beta is second line, gamma is third line of Lyman series. So electron jumps from any higher orbit to the first series is called Lyman series. It is in ultraviolet region. Any higher orbit to the second, then Balmer series. First line H alpha, then H beta, then H gamma. Any higher orbit to the third, then it is called Paschen series. Any higher orbit to the fourth, then it is called as bracket series. Any higher orbit to the fifth, then it is called Fund series. This belongs to visible, this belongs to infrared, this is near infrared, this is called far infrared. Please draw this diagram. Lyman series means its lowest orbit is 1, higher can be 2, 3, 4, 5 up to infinity. Balmer N1 is 2, higher can be 3, 4, 5. Same way Paschen 3, 4, 5 and so on. Yes, completed.
No,
Yes, sir.
sir. Done, sir.
That's all for today. So please revise simple chapter which we are doing. This is very simple chapter. Revise and then